yes, I will talk about how to draw buildings from ordinary photos. And I will show that in many cases, one photo is more than enough to draw a building outline. So under ordinary photo, I mean just normal photo you take from the ground with a quite ordinary digital camera or even a mobile phone. So first, a few words about motivation. So for me, it seems that most of Europe more or less covered by high-resolution satellite imagery. But that's not the case for the rest of the world. And here, the Bing snapshot from Bing satellite imagery for my native town that has been mapping for 3 years. So no high-resolution imagery is available. Next, there could be high-resolution imagery available, but for some interesting parts could be hidden by clouds, or could be hidden, or just could be dark. And that prevents from using this high-resolution imagery to draw the outlines of buildings. And finally, some buildings may have very complex structure, like this Orthodox cathedral. And I think it's hardly possible to draw the correct outline from high-resolution satellite imagery, and one needs something more. So I will talk about initial approach I tried. It's not the approach I would suggest to use. First, I tried a bundler software from the University of Washington. It was a predecessor of Microsoft Photosynth. If you don't know what's Microsoft Photosynth, it's an immersive application, and it allows immersive touring from one photo to another photo in 3D space. So this software involves very complex computer vision algorithms. It takes a set of images, image features, extracted from the images, and image matches as input and produce as output a sparse set of points and a position of cameras in 3D. Let's explain it in examples. So there are five photos taken in England in some small town where another collaborator lives. That's old city hall. Okay, then comes a very complex computer vision algorithms, and we are on OpenStreetMap conference, not in computer vision conference. So I will just describe it in very few sentences. First, find features on every image, and they could be ranging from 3 photos to many hundreds or even thousands. And one requires very powerful computers to process thousands of images. But if you have only several images, like 10, 20, so your desktop computer would be enough. Then, find matches between the images, find matches between features of each image. It means, so we take features from the previous step. Sorry. There could be many thousands of features. And we take every feature on every image and compare it with every feature on every other image. So you can imagine this takes a lot of time. And this software estimates which features compose a single point in 3D space. And finally, we get a chain of features that correspond to a particular point in 3D space. And the final step is so-called bundler adjustment. That's a computer vision term. And from this step, we get sparse 3D points and position of cameras in 3D. And there is an optional step, so-called clustering views for multi-view stereo. That's CMVS in short. It's also a software from the University of Washington that could provide as dense points in 3D space. So some results. Here's the result of reconstruction from 5 images I've shown earlier. Well, one could recognize the building I showed a few instances before. A more impressive example involves 251 pictures. It's somewhere in France. So we developed some kind of library that simplifies the use of this software toolkit from the University of Washington, and it could be downloaded from this address. Just type OSM bundler in your favorite search engine, and I think you will get the link to this address. Well, this picture looks very nice, but the truth was not that nice. This toolkit was unreliable. It might involve a lot of time for processing. The more pictures, the more time it takes. And I would say that it's more like a tool for researchers than a tool for ordinary member of OpenStreetMap community. Next, getting to a building outline from 3D points is separate task. So we get a point set, but then we need a way to bring this set to JSON. And I must say that this task was not solved. One could make a snapshot from the bird from the top and use this snapshot in JSON to draw the outline. That was the solution we used for a while, until we adopted the next solution. I will talk in a few minutes. So, and finally, 3D reconstruction is excessive for OpenStreetMap, because OpenStreetMap for now is much more a 2D map than 3D map. Okay, now time to talk about the final approach I would recommend to use. I've written a plugin for Google Sketchup that can import and export OpenStreetMap geometry. And for those who don't know what Google Sketchup is, that's a 3D editor that greatly simplifies the creation of 3D buildings. And I would dare to say that mostly all buildings you could see in Google Earth are done with Google Sketchup. It provides some very neat tools that simplifies the creation of 3D models, some guides and so on. So if you want to use this approach, install Google Sketchup, watch very good introductory videos on the website of Google Sketchup, then download OpenStreetMap Google Sketchup plugin. Following this link, just type SketchUp or Google Sketchup in the search box of OpenStreetMap wiki. Okay, learn how to use basic functions of SketchUp. And finally, Google Sketchup provides a very nice tool, so-called photo matching feature of so-called photo matching. With this tool, one could reconstruct the whole 3D model from 1 or 2 ordinary photos. It's based on projective geometry laws. And finally, let's take an example how it works. Let's look at an example how it works. Take a picture. I will show that one picture is enough. from building angle. So there is a niche here, an asymmetric niche in this building. So there are how many? 7 windows on the left side and only 5 windows on the right side. And the very important condition, the picture must not be cropped. If it's cropped, there will be mistakes. And finally, open SketchUp. Here select camera, match feature, load this picture, and do some preparational step. In this step, we mark 2 lines that are parallel to horizontal plane, or in other words, parallel to red horizontal axis, and mark 2 lines parallel to green horizontal axis. And then place the 0 point or the beginning of coordinates somewhere on the edge of the building. And then press down here. And finally, we are ready to draw the building outline. As I said, Google Sketchup provides some nice features that greatly simplifies the reconstruction development of 3D models. So you could see here some guides are shown. It shows me that I am in a particular plane. I'm doing the right things shortly. And so I skip some steps. Finally, our building outline is ready here. And let's view it from some angle. Here it is. Okay, now we have to georeference it, to place it in somewhere on the right position inside OpenStreetMap. So press import, select OpenStreetMap importer, either OpenStreetMap file or GPS tracks here. And they're coming from the plugin that I wrote. Select our file, OpenStreetMap file, and so the OpenStreetMap geometry is imported inside Google Sketchup. And our GPS tracks are also imported inside Google Sketchup. And so finally, place our reconstructed model on the right place, give it a right scaling, and that's it, we are ready. And you see here, one could switch on and switch off the layers, like in SotM. Okay, the final step here in the menu, in the file menu, find export to OpenStreetMap file. So, and it will offer you to save the file in OpenStreetMap format. Then open this file in SotM or your favorite editor. And finally, save it in the database, in the OpenStreetMap database. And here, this building rendered by Mapnik. Okay, that's it. I recommend to use it, try it, and give feedback. And this tool could be found at this address. Just type Google Sketchup in the search box of wiki website of OpenStreetMap.
Thank you, Vladimir. It's very interesting that there are new ways, not just GPX alone or GPS traces and satellite images, but there's a lot of other things we should explore, how to get more data into OpenStreetMap. So, questions. There was one down here.
What about the heights of the buildings?
We could measure them using the photo. And this is not yet implemented, but I think the height can be measured and used inside a specific tag for the building. Yes, that's possible.
Other questions? I guess not. Thanks again, Vladimir.